Let's recall what we know about trigonometry. Trigonometry studies three ratios associated with one of the acute angles in a right triangle. The tangent of an angle is, so first we write down our acronym, TOA. This is just a way to remember the ratio relationships. The tangent is the opposite over adjacent. The cosine is adjacent over hypotenuse, and the sine is opposite over hypotenuse. Here it is, sine opposite over hypotenuse, cosine adjacent hypotenuse, tan opposite over adjacent. What happens if you're given one angle and one side in a right triangle? We can use trigonometry to find the other two bits of information. So for instance, if we want to find x first, we know that the cosine is adjacent over hypotenuse. So if we set up a relationship of cosine of 26 degrees equals x over 17, we simply have to find out what the cosine of 26 degrees is. It's a ratio, it's a number. It's actually, if I look it up on the table, I get 0.8988. And that equals x over 17. Multiply both sides by 17, and you got x equals approximately 15.3. I'd like you please to, if you're using your calculator, I want you to go out to 4 decimal places whenever you are dealing with cosines and sines and tangent. 4 decimal places, which is just what a table goes out to. If we want to find y by using trigonometry, we could use Pythagorean theorem to find y, or we could set up a relationship between the opposite and the hypotenuse, and that would be a sine relationship. The sine of 26 degrees equals y over 17. The sine of 26 degrees on the table is 0.4384 equals y over 17. Multiplying both sides by 17, you get y is approximately 7.45. Okay, example number 2. Example number 2 gives us 2 pieces of information, and it wants us to find the measure of angle K and the measure of angle L. Okay, so they give us the adjacent leg to K, and they give us the hypotenuse. So, which trig ratio is adjacent over hypotenuse? That would be cosine. So we could do that angle K is equal to the cosine -1 of 21 over 36, and that's approximately 54.3 degrees. So subtracting 54.3 from 90, the other angle must be 35.7 degrees. Okay, so here's a diagram that shows 3 triangles, 2 right triangles, and we have to find some information about those 2 right triangles. So I would think step 1 might be to find x and y, and let's do that. So we're given the adjacent, we're given the opposite here. We're given 8. 8 is opposite to 38. So we need to use one of the trig ratios that have opposite. So tangent is opposite over adjacent, so we could simply do that the tan of 38 degrees equal the opposite over x. Now I can solve that out if I want to, but see how the x is in the denominator here? It's always a little bit more work when x is in the denominator. I could figure out that this angle here is 52 degrees because it all adds up to 90. So easier would be if I did the tan of 52 degrees equals x over 8. Do you see that? This one's a little bit simpler to solve. Pick one of those and solve them out. Once you get x, you need to find y. And once you get y, we need to think about how to find z. Well, let's see. For z, oh, we're all set for z, aren't we? Because for z, we're given the leg adjacent to 8, and we want to find the hypotenuse. We're given adjacent and want to find the hypotenuse. So for this one, we would use the cosine, because that's adjacent over hypotenuse. The cosine of 40 equals 8 over z. So again, the z's in the denominator. I might recommend figuring out what this angle is and set up another trig ratio so that the z is in the numerator. And we'll discuss this tomorrow, next class.